A quantity of PCl5 was heated in 10 liter vessel of 250 degrees Celsius. PCl5 gas will give PCl3 plus Cl2. At equilibrium, the vessel contains 0.1 mole of PCl5, zero point 0.2 mole of PCl3 and 0.2 mole of Cl2. The equilibrium constant of the reaction is. So in the given reaction, we can write Kc is equal to PCl3 PCl2 Cl2 divided by PCl5, which is equal to 0.2 upon 10 into 0.2 upon 10 divided by 0.1 divided by 10. On solving this, we get 0.04. Option C is the correct answer. In the gas phase reaction, C2H2 plus H2 will give C2H6. The equilibrium constant can be expressed in unit of. So it is a gas phase reaction. We can write the equilibrium constant K is equal to C2H6 upon C2H4 into H2. Unit is mole per liter divided by mole per liter into mole per liter. So K will have units of liter per mole or liter mole raised to minus 1. So option B is the correct option. A 1 mole solution of glucose reaction dissociation equilibrium according to equation given below, 6HCHO give C6H12O6. What is the concentration of HCHO at equilibrium if the equilibrium constant is 6 into 10 raised to 22? The reaction is 6HCHO reversible K2 gives C6H12O6 in forward reaction, and the backward is C6H12O6 K1. The reversible reaction C6HCHO is a backward reaction. K2 is equal to 1 upon K1 raised to 1 by 6. Therefore, K2 is equal to 1 upon 6 into 10 raised to 22 raised to 1 by 6. On solving, we get K2 is equal to 1.6 into 10 raised to minus 4 moles. So option D is the correct answer. 2 mole of PCl5 are heated in a closed vessel of 2 liter capacity. At equilibrium, 40% of PCl5 dissociated into PCl3 and Cl2. The value of equilibrium constant is. So the reaction will be PCl5 PCl3 plus Cl2 200. Initial concentration 2 into 60 upon 100, 2 into 40 upon 100 and 2 into 40 upon 100. Volume of container is equal to 2 liters. Therefore, Kc is equal to 2 into 40 upon 100 into 2 into 2 into 40 upon 100 into 2 divided by 2 into 60 upon 100 into 2. On solving this, we get Kc is equal to 0.266. So option A is the correct answer. A reaction is A plus B will give C plus D. Initially, we start with equal concentration of A and B. At equilibrium, we find the moles of C is 2 times of A. What is the equilibrium constant of the reaction? So the reaction is A plus 2B in the reversible reaction A plus B in the reversible reaction C plus D. Initial concentration is A, 2A and 2A. Therefore, K is equal to 2A into 2A divided by A into A, which is equal to 4. So option A is the correct answer. Next question is 4.5 mole each of hydrogen and iodine heated in a sealed 10 liter vessel. At equilibrium, 3 moles of HI were formed. The equilibrium constant for H2 plus I2 give 2HI is. So reaction is H2 plus I2 in a reversible reaction give 2HI. Initial concentration is 4.5, 4.5 and 0. The at equilibrium constant 4.5 minus x, 4.5 minus x will give 2x. So 2x is equal to 3 from equation. So x is equal to 3 by 2, which is equal to 1.5. So concentration at equilibrium is equal to 4.5 minus 1.5 is equal of hydrogen. So which is equal to 3, and this is the value of Hi. Therefore K is equal to Hi square upon I2 into H2. On solving we get 3 into 3 divided by 3 into 3 is equal to 1. So option A is the correct answer. The equilibrium constant Kc for the reaction Ha plus B gives BH plus A is 100. If the rate constant for the forward reaction is 10 raised to 5, then the rate constant for backward reaction is. So we know that Kc is equal to Kf, that is forward reaction, and Kb for backward reaction. Therefore Kb is equal to Kf upon Kc, which is equal to 10 raised to 5 upon 100 is equal to 10 raised to 3. So option B is the correct answer. In a chemical reaction equilibrium, the rate constant of backward reaction is 7.5 into 10 raised to minus 4. So the rate constant of backward reaction is 7.5 into 10 raised to minus 4, and the equilibrium constant is 1.5. So the rate of the forward reaction is. So for this reaction we can write that Kc is equal to Kf upon Kb. So Kf forward reaction is equal to Kc into Kb equal to 1.5 into 7.5 into 10 raised to minus 4. On solving this we get 1.125 into 10 raised to minus 3. C is the correct answer. The equilibrium concentration of Xy and Yx2 are 4, 2 and 2 moles respectively. For the equilibrium 2x plus y gives Yx2, the value of K is. So in the given reaction we can write Kc is equal to Yx2 divided by x raised to 2 and y, which is equal to 2 upon 4 into 4 into 2. On solving this we get 1 upon 16. The value of 1 upon 16 is 0.0625. Option B. 28 gram of N2 and 6 gram of H2 were kept at 400 degrees Celsius in 1 liter vessel. The equilibrium mixture is 27.54 gram of ammonia. The approximate value of Kc for the above reaction can be in. So in the given reaction will be N2 plus 3H2 will give 2NH3. Initial concentration is 130, and at equilibrium we get 1 minus 0.81, 3 minus 2.43 and 1.62. So we get 0.19, 0.57. Number of moles of nitrogen is 28 upon 28 equal to 1 mole. Number of moles of hydrogen is equal to 6 by 2, which is equal to 3 moles, and number of moles of ammonia is 27.54 upon 17, which is equal to 1.62 moles. So Kc is equal to ammonia upon nitrogen into hydrogen Q. So substituting the value we get 0.19 into 0.57 cube, which is equal to 75. So option A is the correct answer. Which of the following is irreversible reaction? 8 to ammonia will give nitrogen plus 3 hydrogen. PCl5 will give PCl3 and Cl2. KClO3 will give KCl plus O2, and SO3 will give SO2 plus O2. Irreversible reaction is KClO3 will give KCl plus O2. Potassium chlorate, which is KClO3, is obtained by electrolysis of a hot solution of KCl. So option C is the correct answer. A reversible reaction is one which A proceed in one direction, B proceed in both direction, C proceed spontaneously, D all statements are wrong. Reversible reaction always attains equilibrium, which proceeds in both the direction and never go completion. So option B, proceeds in both direction, is the correct statement. For the reaction, C plus CO2 will give 2CO. Kp is 63 at 1000 Kelvin. If the equilibrium of PCO is equal to 10 times of PCO2, then the total pressure of the gas at equilibrium is. The given reaction is C plus CO2 will give 2CO. Always apply law of mass action. From that we'll get PCO will give square PCO2, or 63 is equal to 10 times PCO2 square upon PCO2. Therefore 63 is equal to 100 PCO2 square upon PCO2, or 63 is equal to 100 into PCO2. Therefore value of PCO2 is equal to 0.63 atmosphere. Now PCO is equal to 10 times of PCO2. So we can write 10 into 0.63, which is equal to 6.3 atmosphere. Now total pressure is equal to PCO2 plus PCO. So it is equal to 6.93 atmosphere. Option B is the correct answer. Dissociation enthalpy is 2.56 into 10 raised to minus 2 atmosphere. If the total pressure at equilibrium is 1 atmosphere, then percentage of dissociation of AB is. So they are talking about the equation AB will give A plus B. Applying law of mass action, we'll get Kp is equal to alpha square P upon 1 minus alpha square. Alpha square is equal to 1 upon 1 minus alpha, which is equal to 2.56 into 10 raised to minus 2. Alpha square is equal to 2.56 into 10 raised to minus 2. Therefore alpha is equal to 0.16. Therefore percentage of dissociation is equal to 16%. So option E is the correct option. If for H2 gas plus half S2 will give H2S, and H2 plus Br2 will give 2HBr, the equilibrium constant are K1 and K2. The reaction for Br2 will give plus H2S will give 2HBr plus half S2. Would equilibrium constant be? So K1 is equal to H2S upon H2 into S2 raised to half. K2 is equal to HBr2 divided by H2 Br2, and K3 is equal to HBr square into H2 raised to half divided by Br2 into H2S, which is equal to K2 upon K1 equal to K3. So option C is the correct option. Which of the following is not affected by change in pressure? A H2 plus I2 give 2HI, B 2C plus O2 give 2CO, N2 plus 3H2 will give 2 ammonia, D PCl5 will give PCl3 plus Cl2. In the reaction number 1, H2 plus I2 will give 2HI. The number of moles is equal to 0. So this reaction is not affected by change in pressure, as the number of moles is equal to 0. 2 moles of ammonia when put in a previously evacuated vessel 1 liter partially dissociated into N2 and H2. If at equilibrium 1 mole of ammonia is present, the equilibrium constant is. So in the given reaction, 2 ammonia will form N2 plus 3H2. Initial concentration is 200, and at equilibrium it is 1 half and 3 by 2. So Kc is equal to N2 H2 thrice and ammonia twice. Substituting the value, we get half into 3 by 2 raised to 3 divided by 1 square is equal to 27 by 16. So option D is the correct option. So our next question is 3.2 moles of hydrogen iodide were heated in a sealed bulb of 444 degrees Celsius till the equilibrium state was reached. Its degree of dissociation at this temperature was found to be 22%. The number of moles of hydrogen iodide present at equilibrium is degree of dissociation, that is alpha, is equal to 22%. So we can write 22 upon 100 into 3.2 is equal to 0.74. So at equilibrium, moles of Hi is equal to 32, 3.2 minus 0.704 is equal to 2.496 moles are present, as the equation will be N2 plus 3H2 in a reversible reaction of 2 ammonia. So option A is the correct answer. The reaction 2SO2 plus O2 gives twice of SO3 is carried out in 1 dm³ vessel and 2 dm³ vessels separately. The ratio of the reaction velocities will be, the reaction is 2SO2 plus O2 gives 2SO3. For 1 dm³ R is equal to K SO2 square and O2. Therefore, R is equal to K 1 square into 1 is equal to 1. For 2 dm³, R is equal to K 1 by 2 square into 1 by 2 equal to 1 by 8. So the ratio is 8 is to 1. So option D is the correct answer. So the next question is, calculate the partial pressure of carbon monoxide from the following. CaCO3 gives CaO plus carbon dioxide. Carbon dioxide plus copper give 2CO, where Kp is 8 into 10 raised to minus 2. So in the given reaction, CaCO3 will give CaO in heating plus CO2. So Kp 1 is equal to partial pressure of carbon dioxide, and Kp2 from the next equation is PCO the whole square upon partial pressure of carbon dioxide. So PCO is root of Kp1 into Kp2. Therefore, PCO is equal to root of 8 into 10 raised to minus 2 into 2. Therefore, PCO is equal to root of 16 into 10 raised to minus 2, which is equal to 4 into 10 raised to minus 1. So option B is the correct answer. Next question is, partial pressure of oxygen in reaction 2AgO with gives 4Ag plus O2 is. In this reaction, 2Ag2O in a reversible reaction gives 4Ag plus O2. For this reaction, Kp is equal to partial pressure of oxygen, as Ag2O and Ag are in solid state. So partial pressure is equals to Kp. Next question is, 2 moles of nitrogen is mixed with 6 moles of hydrogen in a closed vessel of 1 liter capacity. If 50% of nitrogen is converted into ammonia at equilibrium, the value of Kc for the reaction N2 plus 3H2 reversible 2NH3 is. So the given equation is N2 plus 3H2 will give 2 moles of ammonia. So 2 minus x, 6 minus 3x and 2x. 50% dissociation of nitrogen takes place. So at equilibrium, 2 into 50 upon 100 is equal to 1. So x is equal to 1. Kc is equal to 2 square 1 into 3 cube. So 4 upon 27. So Kc is equal to 4 upon 27. So option A is the correct answer. The value of equilibrium constant for the reaction Hi irreversible of half H2 plus half I2 is 8. The equilibrium constant for a reaction H2 plus I2 is. So in a given reaction Kc we can write as 1 upon 8 the whole square, which will give us 1 upon 64. So option D is the correct option. We can write Kc value from the given equation. For the reaction H2 plus CO2 in a reversible gives CO plus H2O. If the initial concentration of H2 is equal to carbon dioxide and X moles liter of hydrogen is consumed at equilibrium, the correct expression for Kp is. So the reaction we can write as H2 plus carbon dioxide will give CO plus H2O. Initial concentration will be this. Initial concentration is 1 and 0 is the product. At equilibrium we get 1 minus x, 1 minus x, and the product is xx. Therefore we can write value of Kp as partial pressure of carbon monoxide into partial pressure of water divided by partial pressure of hydrogen into partial pressure of carbon dioxide, which is equal to x dot x divided by 1 minus x into 1 minus x equal to x square upon 1 minus x the whole square. So option A is the correct answer. The equilibrium constant for the reaction SO3 will give SO2 plus half O2 is Kc 4.9 into 10 raised to minus 2. The value of Kc for the reaction 2SO2 plus O2 with 2SO3 will be. So for the given reaction we can write Kc value as O2 raised to half SO2 divided by SO3, which is equal to 4.9 into 10 raised to minus 2, the value of Kc for the reaction. So SO3 raised to square divided by SO2 square and O2 is equal to 1 upon 4.9 into 10 raised to minus 2 the whole square. We get this from 2SO2 plus O2 will give 2SO3. On solving this, we get 416.49. So option A is the correct and appropriate answer.